Okay, this lesson is on tangents. So we're going to learn what a tangent line is and apply its properties. Okay, so what is a tangent? A tangent is a line that intersects a circle or a curved surface at exactly one point. This is called the point of tangency. So here's a circle, and this right here is our point of tangency that intersects only there. Okay, so that is a tangent line. This is something that's talked about in calculus quite a bit. Okay, so tangent properties, there's a few here. The first one is, in this picture, you're going to see this here in a second. A line is tangent to a circle if and only if, remember that's what that double arrow means, if and only if it is perpendicular. I'm going to write that in there. Okay, perpendicular to the radius drawn to the point of tangency. So what that means is, if we look at this picture, right, here is our line. Here is the radius drawn to where the point of tangency, in other words, where it touches the circle. That will always form a 90-degree angle. It's perpendicular. So this is 90 degrees right here. Okay, that's a pretty important tangent property. Okay, so then there's two more also that we want to talk about as well. And this one says, if two segments are tangent to a circle and they intersect at the same point outside the circle, which would in this case would be B right here, then they are congruent. Ooh, that's not a good congruent start. There we go. Then they are congruent. So in this picture here, we know that these are tangent because you can see that it's 90 degrees there where they intersect. So that means then this segment and this segment are congruent. Okay. All right, so then the last one is if there is a polygon that is, let me say, circumscribed. Okay. Oh, I think I forgot a C in there. No, that's right. Circumscribed. Maybe I did. Anyways, around a circle, then all the sides are tangent. So this just means you've got a circle inside, right? And all the sides touch there. That's the circumscribed there. And then I've got a polygon around that. In this case, it's a triangle. It could be other shapes like a quadrilateral or whatever. But then where these lines touch, then they are all tangent lines. They just intersect one time. Okay, so we are going to apply these properties on a few problems here and get used to how these work. Okay. All right, so the first thing it says, if the lines are tangent, then find x. Okay, so I'm going to try to do that. All right, well, I know in this case, right, that it's a tangent line. MB is a tangent line, so this is then 90 degrees. And it's a triangle. So I say, all right, well, if I add 90 plus 53, I get 143, right? So then what do I have left? Well, 180 minus 143, whoops, not 140, 143, there we go, would be 37. So in this case, x is equal to 37 degrees. Okay. All right, here, now you'll see I have, these are, again, tangents, so this is 90 and this is 90. Now, this time I have a quadrilateral, and a quadrilateral, if you remember, adds up to not 180 like a triangle, it adds up to 360. So if this is 90 and this is 90, right, I'm gonna add those together. So 90 plus 90 is 180, plus another 80 would be 260 degrees. So that means that then if I got to get up to 360, I need that to be 100 degrees. That's how that works. That's just using that first property to help us out. And then knowing a little bit of other things. Okay. This says, is segment AB tangent to circle P? Okay, so we want to say, well, in order for that to be the case, this has to be in 90 degrees. We don't know that we don't know if it's a tangent. So you'll notice this is a triangle. In order for this to be 90 degrees, then the Pythagorean theorem should work. So if I go 8 squared plus 15 squared, and then equals my hypotenuse squared, if that works, then the answer is yes. So this is 64, this is 225, and this is 289. Okay, so let's see, this is 289, and that equals 289, so yes, this is a tangent line. AB is tangent to circle P there. Okay? And that's how you do that. And sometimes they try to make it a little bit more complicated and you got to do a little bit more thinking. Okay, so this is the radius. It's 11, which means this right here is also 11. So before I can start with this, I have to know that, which would mean then that this whole thing here is 16, right? So I could then set this up as 11 squared plus 14 squared equals 16 squared. 121, 196, and then this is 256. Okay. So now if I add 121 and 196, that's 317, which is definitely not equal to 256, so this would be no. That is not a tangent line. Now, it does look like it's a tangent line, doesn't it? And we want to make sure that we're not just assuming from a picture because that can be misleading. So we want to confirm with the math. Okay. And they do try to make some of these a little bit trickier, so I did want to go over a couple of other ones. So it says here, if JK, segment JK, is tangent to circle L, find X. So we do know that this time it's tangent, so this is 90 degrees. Find X. So I'm just going to use the Pythagorean theorem here again to try to figure that out. So 11 squared plus X squared equals 7 squared. But no, not 7, right? So if we've got to add that 11 right there. Remember, the hypotenuse should always be the longest side, so you want to remember, oh, that's 7 over there. That's smaller than the other side over there. That's probably not right. So that means this whole side is 18 squared. Okay, now we can go ahead. So this is 121 plus X squared equals 324. Okay, let's do a little algebra. X squared equals 203. And then I want to get rid of that squared, so I'm going to square root. And then we would get 14.2. Okay. That's our x. All right. This one is a little harder. I know that this is 10. Okay, I'm going to do this because I have an x here. This is a little trickier. So I'm actually going to say this whole side is y. And I'm going to figure out what that is first. So because I know the other side. So I'm going to say 10 squared plus 24 squared equals y squared. And then I'll solve for x. All right, so 10 squared is 100. 24 squared is 576. So this is 676. Okay, if I take the square root of both sides, I get y equals 26. Okay, so now I'm here. I know that this is 26. If I want to know what x is, so now I'm just going to say, well, x plus 10 has to be equal to 26. Subtract 10 from both sides, so x is 16. Cool. So that's one way to do it. There are other ways to do that, but I think maybe that might be a little easier way to try those. Okay. And then this one is kind of using one of those other properties to help us. Okay. So it says, find the length of PQ. Well, and in this case, what appears to be a tangent line, we assume is tangent in this case. And that'll say that on your assignment. So if that's the case, then, whoops, it's all right. Then this and this are congruent. So we would set this up by saying, all right, well, that means 14x minus 13 has to be equal to 8x plus 5. All right, and back to the algebra. Okay, and then I'm going to add 13. And then divide by 6, so that's going to give us x equals 3. Now, we do need to find PQ here, and PQ is 14x minus 13. So we know that it's 14 times 3 minus 13. Okay? So that's going to give us 29. So PQ has 29, which means then that RQ is also 29, but they just wanted us to know that one. Okay. All right, this one says find the perimeter of DEF. Okay. So this this triangle is circumscribed around the circle. So that means all of these are tangent lines. And if they're tangent, right, this, let's maybe go with my highlighter. This right here segment should be congruent to this segment. And that's kind of all the way around. So this is congruent to this by the property that we just kind of went over. And then this is congruent to this. So that means I can just sort of fill in some of these things. I know that this then is 11, this is 16, and this is 9.5. So now I can just add all of that up. 32 plus 22 plus 19. So this would be, perimeter would be equal to 73. And that's just using that property, knowing that they're tangents, and then combining that with the other property, knowing that then they're congruent. And that's that. I hope that makes some sense. Don't forget to write this into your planner.